All right, should we get this thing started? I think we should. It's recorded anyway. IRL, yeah, exactly. Okay, great. Well, so welcome to Tuesday, March 18th, 2025, Sriracha Demos. Hello to everybody watching from home, and hello to our team here. Also, hello, Jennifer, joining as a viewer. We're excited to have you. We always aspire for lots of external viewers like during the actual demo, but we don't actually get that many. But I promise we've got a really good one for you today. We've got a bunch of stuff lined up. This is our first demos meeting in about a month, I think, which is part of why it's so packed full of stuff. Today, I'm going to be showing off the Bluesky Backups app. Alan is going to be showing off Python IPFS tooling for AI. And Forrest is going to be showing off the warm storage node on the Filecoin calibration network. So without further ado, I think I'm kicking it off. So let's get started. So I have been talking about this demo app for a little while now, and I think most folks might have already seen this, the storybook. I posted this in some PRs and some videos, but just in case you haven't seen this, we have this nice UI framework for working on the app now. It kind of works at every level of abstraction here, where we can show off what the initial pages look like, and then we can sort of show off what they look like in different states. As you can tell, we have the plan dialog in here. We've got full account sign up going. I'll talk about that in just a little bit, but if you are curious about this stuff, we have Chromatic set up, and you can go actually browse all these different components. And so you can kind of get a flavor for what the app looks like. But that's not what we're here for today. We're here to see real working code and a real demo that may or may not work, because it's really happening. And I literally just put the final touches on it just minutes ago. So wish me luck, and let's see if we can do this. So welcome to Hot Bluesky Backups by Sriracha. To get started, you have to sign up or you have to sign in with a Bluesky account. The whole point of this is to back up your Bluesky account. So of course, a Bluesky account is a necessary part of that. So basically, we go through the OAuth flow. This is something that Bluesky provided. You can see that we're on the bluesky.social app here. And this is going to return us back to my ngrok URL, which is kind of how this whole thing is working right now. Once that's done, you can log into your Sriracha account. Now, if you don't already have a Sriracha account, this will create a Sriracha account for you. You can do just about everything in this app now, except for create a space. And we have a PR open for space creation right now. I will say that the way we do space creation right now, you probably shouldn't create a space in a browser, because we use RSA keys in the browser. And they are kind of awkward to work with and don't give you the opportunity to save a mnemonic. So what I would recommend right for now, until we have sorted some of that out, is that you actually create an account using our CLI and then log into this app. But as with our normal process, I have an email in another window over here. I'm clicking verify, and hopefully this will see it in a second. And yes, send me into the Backups app. Don't worry about these errors. I'm sure they're not a big deal. So let's start backups. As you can see here, we have a space picker. If I had more spaces, this would show more spaces. And the easiest thing to do is just to get these backups going. We'll get them all going at the same time. Beep, 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 beep. If you open up the console, you can see some more details about what's going on here. I'll probably remove some of this logging, because obviously this isn't the best place for it. And a lot of this progress stuff will move over here. The blobs are backing up. We're literally taking all of the binary objects that I've uploaded to my repo and bringing them through the browser and then sending them over to Sriracha. So let's see what we just did. Okay. Cool. So I created a repo here. If I do this, it's actually going to bring me over to the gateway, and theoretically it will show me. Yeah, I've noticed this being a little slow sometimes, but this is the actual raw Bluesky repo. Bluesky repos are built on the app protocol. The app protocol uses cars just like we do, and so this is the car that I uploaded. And you know, it's kind of hard to tell exactly what's going on, but you can start to see some kind of Bluesky stuff here, graph follow. You can kind of get a sense that this is Bluesky data that is in here. So that's neat. What about this preferences thing? Well, these are actually the preferences of this dummy account that I created. They're JSON. We backed them up, and this is you know, a link to our gateway here. So you can see that this is working. This is all in staging, by the way, which is probably why it's a little bit slow. When I do the actual demo, I'm going to do a demo this Saturday at the App Protocol conference in Seattle. I'm going to use production so that we don't have that problem. And then finally, these are the actual blobs. These are the blobs. Let's see. I think that last one I had clicked on a few times, so it was already there. Oh yeah, this is my background. This is very appropriate for the moment. And then risky click, who knows what this is? Oh, great, awesome. Okay, cool. Well, that's neat. But what if I want to actually restore to another Bluesky PDS? So the cool thing about Bluesky is that it can work with personal data stores hosted outside the Bluesky network. So Bluesky hosts an app proto personal data store server, but you can move your account to your own personal data store server. And in fact, I have set one up so that we can demo that. The one thing about the restore process is that it's one way. You cannot go back to the Bluesky PDS after you've migrated out. So I'm probably not going to actually demonstrate it right now because it'll break my demos. But I will demonstrate the restore flow. So let's see. So we want to first authenticate to the current Bluesky server. And I know what you're saying. Hey, didn't I already do this? And the answer is yes. But what we did there was OAuth. This is actual password auth. And unfortunately, that is what you need to do if you actually want to restore for now. One of the priorities on the App Proto development list for, I think, the next quarter is to add additional OAuth scopes. And hopefully some of the OAuth scopes that they add will enable us to reuse the OAuth that we already did to do some of that stuff. But basically, I've OAuthed into, or I've authorized the new, I've authorized against the new PDS. And so now I can go from Storacha to that new PDS, and I can just click these buttons and it'll just kind of do the thing. It's hard to kind of verify that that actually worked, but the fact that it didn't error means that it probably did. This last part is kind of the tricky part, and this is where I actually needed to authorize into my old Bluesky server as well. We can do a little bit of work to make this asynchronous as well. We can kind of back up the key that we need to get out of here. But right now, the process is that you click on that, you have to send an email. Let's see, maybe I can actually do this on the fly. If this doesn't work very trivially, I'm probably not going to do this part. Because what we're doing here, oh yeah, no, it did, it totally did. So I got an email with a confirmation code. And if I do this right now, it's actually going to break my old account. So I'm not going to do it. But this will both, this will actually, so the data is already in the new PDS. All I need to do is move my identity from the old PDS to the new PDS. And when I click this, it will actually do that. Okay, cool. So this is all great. But I'm sure you're saying, but Travis, what are these encrypted with? And didn't I just back up my preferences, which is a piece of private data on a public network without any encryption? And the answer is yes, yes. Yes, you did. And that is not great. And let's do something better. So over here, when I was doing my backups, you may have noticed these little buttons. And they don't work right now. And that's because I don't actually have a key. So I have this little keychain thing, and I can create a key. And when I create a key, I can show the secret. And I'm going to copy the secret and not show everybody. I can copy this. I can bring it over to my 1Password. What's neat about this is that it's the key, the actual key itself is stored in memory. So if I come back, I am indexing it in XDB. I'm storing kind of this did there. But if I try to look at the key, there isn't one. There's no key attached to this. And what I have to do is import that key that I just saved. And now I can see the secret. Great. And now I can use it for encryption. Now, if you take a look over in the console, there's one problem. So the way that I've implemented this is with RSA OAEP keys, and those RSA keys in general are not appropriate for encrypting large amounts of data. You really want to use a symmetric key for that. these are things I learned yesterday. I'm sure the crypto nerds in the audience are going to be laughing at me at my noobish browser crypto skills, but it turns out crypto in the browser is still very hard. So what people do, what the nerds do, according to the internet, according to the things I read, not AI, it was actually a human written out doc that noted that what people generally do here is create this RSA OAP key because it is a public-private key. It's an asymmetric key pair, and we've implemented all of this in terms of asymmetric key pairs. I'm identifying things explicitly by their public key. Private, with a symmetric key, there is no public key. It's just one key. And so what people generally do when they want to do things like this, I'm told, is they will create an RSA OAP key and sort of use that as the primary one, and then create a symmetric key that is just a key that doesn't have a pair to it, just a private key. They'll encrypt that private key, store it somewhere, and then basically, when you want to encrypt something, you go get the encrypted symmetric key, decrypt it, use it to do the encryption, and then right. And so we already do this with lit. Exactly. So if this is sounding very familiar to things that we already do with other things, that's good. That makes sense. So the point of this is stay tuned. We have some very exciting things coming, an integration with the lit protocol that will hopefully make this a lot easier. And fundamentally, we're going to be dealing with some of the same primitives. So we should be able to reuse a lot of these, this UI, a lot of these ways of kind of describing what's going on here. But for now, I am going to go implement I'm going to go implement a thing where we create the symmetric key, we encrypt it with this key, we store the encrypted symmetric key on Straccia, of course, and then we store the. You can actually even see over here. I have, if you're curious, what this all looks like. We have backups, we have blobs, and we have keys, and the keys already have a spot for a symmetric key CID. So we will track the symmetric key CID, and when we want to do encryption, we'll go get the symmetric key, we'll decrypt it, and we'll actually use it for the encryption, and ditto when we want to do the decryption and get it back out. So this is a working backup system. Modulo this part, which, to be fair, I mean, I haven't done it yet, and it's totally possible that that is, like every other encryption thing I've bumped into here, going to turn into a bigger slug than I thought. But we have a few different ways that this can go. We have a few different ways that we're going to resolve that particular part of it. Yeah, I'm super excited. This is obviously just a first pass. The UI is pretty rough. There's a lot of stuff that needs to be improved. But ultimately, I mean, this is basically working. So thanks. I'm super excited to do an even more feature complete demo on Saturday, and looking for other folks to contribute here. If you have ideas about where we can take this, about how we can make this better, definitely let me know. And come on over to the Bluesky, I forget, B-Sky web app or something channel on Discord. Quick shout out. I just want to shout out our PLDG contributors, especially Caleb. Caleb has just been absolutely going wild on the code base. Has made a bunch of contributions and has some contributions outstanding, including a space creator, a whole space creation flow that will work in browsers that support elliptic curve encryption, which is for now Safari and Firefox. But I don't want to give short shrift to the other contributors either. Crostons and Filavery and Discord, y'all have been also crushing it, and I have a couple PRs that I need to get to there. So thank you for all your help, and hope you stick around. We got a lot more work to do, and you've been great contributors. Thanks. That's it for me, and I will stop sharing if I can figure out how to stop sharing now that I'm there. So stop presenting.
So I will be presenting from a different computer because I'm on my laptop and my code is deployed on my local instance. Cool. So we are going to be demoing a Straccia warm storage node that is using Curio and Lotus to interact with the Filecoin calibration chain. This is work that is in progress, just showing a couple of PRs that this is based on. We have one that sets up a Curio and a Lotus node that we will connect to. And we have another one that's implementing a job queue that we will submit jobs to. I'm not going to deploy the Terraform code in this demo because that takes a while. But when you've deployed it, you can go to pdp.straccia.network. You can go there right now, and you'll see that there's a Curio node running there. I've port forwarded Curio's configuration to my local machine, and this is what a Curio node looks like. There's a lot of information here. The interesting bit is that we have been doing PDP proving tasks, and we've failed quite a bit, and that's because our wallet ran out of money. But that won't be an issue when you have a well-funded wallet. What you'll see when you configure Curio is that there's a PDP configuration. And what we've done is we've given it the public key of our Sriracha warm storage node, and we've given it an address with some funds that it's going to use to interact with the PDP smart contract on the Filecoin calibration network. You can look at this address in the block explorer and see that it had some funds, submitted a bunch of proofs, ran out of money. That's why they failed. And then we topped it back up with funds. Thanks, Hannah. And now we're happy again. And you'll also notice that this address is the same address here. Additionally, our node has been running and been proving. And this is a view of all the proofs in the PDP smart contract. We are proof set number 10. And you'll notice that our address is listed as the owner here. And we have quite a few roots. And we are currently pending submitting a proof over our data. Next challenge is here. There's the current height. And we haven't proven anything this period. So that's all pretty neat. But let's add some data to this node that will eventually get proven into the smart contract. And the way we are going to do that is we are going to start our Sriracha warm storage node, which is going to be up here. We're telling it to start, to connect to the Curio instance we've deployed. We've given it a key that it can use to access the Curio instance, and we've said that our proof set is 10. And we'll start that up. And now we have a Sriracha node running. Over in this terminal are the logs from the Curio node and some information about how much Curio is using as far as resource requirements go. And we've noticed that we're all ready. This right-hand side is output from Terraform. And now that we have our storage node running, we are going to mimic an upload service. And we are going to tell it that we would like to add a blob to the storage node. In this space with this node ID, we have proof that we are allowed to do this. We are interacting with a storage node that is running on my local machine. And we are going to add a file called Spicy Rooster 2. And so when you run this, it is going to upload the file to the Curio node. This is going to take a little bit. Hooray, it worked. And so what we've done is we've uploaded this image to Curio, and it is now available for retrieval here. Eventually, this file is going to get added to our proof set, and a proof will be submitted for it by around this time, which is a little bit from now. So we're not going to wait for that whole thing to play out. But it says that it's been uploaded, so we can go look at that. And we have downloaded this file from our Curio node. And if we open it, we should see a picture of a spicy rooster. Yeah, that's about it. If there's any questions, feel free to hop into chat and ask them away. We're going to be continue working on this. I think Alan is up now.
Great job.
AI did make the rooster.
I'm ready for our AI overlords if they can make those things.
Yeah, there's a couple that it made. These are both being served from our Curio node.
Great. Thanks everybody for listening. And next up we have, oh shoot, I think it is Alan with a demo of the AI tools in Python.
Talking of AI, okay, so Sriracha recently made their first foray into the AI world, and it was basically essentially an integration with ELIZA OS. So there's now a plugin that you can install and use in your ELIZA AI agents, which is super cool. But what we found is that actually in the AI world, there's a lot of tooling that's written in Python, and in the IPFS world, there is not a lot of tooling written in Python. So what we're doing is we are trying to rectify that in some way. We've got a few things that we're working on in tandem with the PLG DG developers. First thing we started with was encoding cards. It's one of the things we end up having to do on a client when we want to upload stuff to Sriracha. Is encode a card, send it off. So this is just a test that shows you can encode a card. So you create a block. A block is just a SID and some data. So we're just creating a block here, and then we've got a couple of blocks. Encode a car. We've got familiar kind of list of routes in the car header, and then a list of blocks that we want to encode, and that's kind of how cars work. And then you can decode that car once you've got some bytes. So yeah, this is just a round trip test. We can run it, which is super cool. This is all kind of in memory at the moment. We can add streaming a bit later if we want. But yeah, in terms of like Sriracha's use cases, we actually don't need that, because what we typically do is we shard up to like 128 meg chunks and then send them off. So it's not too desperate for that right now. So we've got base level car encoding, decoding in Python. Next up, if we want to create a UnixFS DAG in Python natively, typically what people do is shell out to existing tools like Kubo or even JS even to get things done. This is again going to be native encoding of protobuf encoded DAGs, which is typically what you find in IPFS UnixFS DAGs. They're all most of the nodes in the graph are protobuf encoded nodes, and so it kind of works like this. You import the thing. Again, we're essentially creating a block. But yeah, we can. What are we doing here? We can decode some encoder. Oh, here we go. Yeah, sorry. Create a new PDP node, encode it, and then we can create a block just to say this is the SID for that block, and then we can decode it. So we've got the whole round trip here. We've got a bunch of test coverage here, which is great. Which is a lot of the tests, well, in fact, the whole kind of implementation is based off of the kind of JS version, so they're very similar. We've taken care to kind of ensure we're testing the same things as the JS version is, so that we have exactly the same coverage as the JS version. Shout out to the PLDG guy called Zero. The Zero, like not the first, the Zero. Anyway, he's been really helpful filling out all of these tests. We've got some what have we got? We've got some edge cases tests that still need to go in, and then we'll publish this to PyP, which is Python's package manager thing. If you didn't already know. The IPLD car thing is already published. And then last but not least, the actual create a DAG. So DAG-PB typically encodes one node of a UnixFS tree. IPLD UnixFS will encode the whole tree. And I'm kind of working on this at the moment, currently creating the kind of balanced tree creator. Which would end up like you might end up with a tree looking something like that. There's a chunker implementation here already. So basically the idea that you've got a file that's quite big. After an X number of bytes, you'll use that as a leaf in the node of the tree. And after the next set of bytes, another leaf, another leaf. But yeah, this none of this is very useful until this bit is finished. So yeah, not announcing it publicly yet, except for just to say that if anyone wants to come help in this endeavor, we can get some native Python tooling for building IPFS DAGs and uploading them to Straccia. Something that has been lacking in the Python world in general, but specifically in the AI world, which is very Python oriented at the moment. So that's my demo. Not much to it. Hope you liked it.
Woo! Thanks, Alan. All right. Do we have any more demos today? I think that's it. But if somebody has a last minute thing that they'd like to show off.
Hannah has her hand
Cool.
up. No? Oh, okay.
No.
Cool. Okay. Well then, great. I think that's it for today. We've got a few minutes before retro. But I think there's just one last thing to do. And that's a go team.
Team.
Thanks everybody. See you soon.
Yeah.